In section 7.1, we're going to be looking at graphing and writing out exponential models. So just to recap from Algebra 1, an exponential function looks like this. Y equals a times b to the x power. Your a value you could think of as your y-intercept or your starting point, and your b value we're going to call our base. Our base value is always going to be greater than 0, and you can think of that as your rate. So our rate is going to tell us some important things of how that graph is going to look. So these two details are important here. If our a value is greater than 0 and our b value is greater than 1, that's going to represent exponential growth. On the other hand, if our a value is greater than 0 and our b value is somewhere between 0 and 1, so that means it's a fraction or a decimal less than 1. So not a negative number, but a fraction or a decimal between 0 and 1. That's going to represent exponential decay. So we're going to use that information to be able to graph an exponential function. So here I want to graph the function y equals 2 to the x power. So when we're working with exponential functions, you're going to see in this unit that taking it a couple x values out, we're going to be dealing with really big numbers. So we're not necessarily going to make a table and graph out points like we did with quadratics or cubic functions or linear functions. Here, all that we're going to do is plot the y-intercept. That's the only point that we're actually going to plot. And then we're going to look at our rate and then make a line representing growth or decay, and that's going to be it. So for the line y equals 2 to the x power, my first step is I want to ask myself, what's the y-intercept here? So in this one, it looks a little bit weird because I only see one number, but y equals 2 to the x power we could think of as y equals 1 times 2 to the x power, leaving our y-intercept here to be 1. So I'm going to plot the point 0, 1. So that's going to go on my graph here. And then the only other thing that I'm going to do from this step is I'm going to ask myself, is this exponential growth or decay? My b value is 2, which is clearly greater than 1. So what I'm going to do is I'm going to draw a line representing growth. So what's important here is that we're not going to cross the x-axis. I'm going to draw a line that looks like this. And as long as it kind of swooshes up, I'm good to go. So the second thing that we're going to talk about is growth and decay models. This is going to be especially important for anything dealing with finances, especially if you're taking financial algebra next year. You're going to use this a lot. The technical model for this is a of t equals a times 1 plus r to the t power. What all these variables mean is our a value is our starting or our initial amount. Our r value represents our rate of growth. And then our t value represents the number of time periods that this growth or decay is occurring. So this model right here would represent growth. If we were looking at exponential decay, instead of adding your rate to 1, you're going to do 1 minus r. So that's the only difference between growth and decay with these models. So the last thing we're going to talk about in this video is modeling exponential growth from a word problem. So in this scenario, let's say next year you're graduating high school and you get $1,000 from family and friends for graduation. You're going to invest that $1,000 into a savings account. The account pays 5% annual interest, and you want to know how much money will be in your account after 6 years. So you put $1,000 in the account. It has a 5% growth rate annually, so every year it's going to grow 5%. In 6 years, you don't do anything with it. You want to figure out how much is going to be in there. So what you're going to do first is you're going to be kind of picking apart what important information is going to go where. So first, I see that it's an annual interest, and I want to know after 6 years. So my t value is going to be 6. Next, I start out by investing $1,000, so that's my starting amount in my savings account. And last but not least, the account is paying out 5% interest, so I have an exponential growth rate of 5%. From here, you want to remember that when we're writing out a percent in an equation, 5%, picture my decimal place here. If I want to write it out as a decimal, I'm going to take the decimal place and move it back twice. So 5%, I would do 1, 2. So my rate would be 0.05. From here, I have that model that we looked at before, and I'm going to plug in the information where I have it. So I'm going to plug in the 1,000, the 0.05, and the t value of 6 where they go. leaving me with this. 1,000 times 1 plus 0.05 to the 6th power. I could rewrite that like this. 1,000 times 1.05 to the 6th power. I'm going to plug that all into my calculator, and I'm going to get, rounding to the nearest hundredth because we're dealing with money, $1,340.10, which is pretty cool because you don't do anything to that, and all of a sudden you made like $350. If this was dealing with decay, the only difference is that instead of doing 1 plus 0.05, we would do 1 minus 0.05, which we're going to look at an example in class.